Okay. Hello. So I'm recording the class now, y'all. Cool. So guys, here we have this angle, and I just wanted to point out, guys, if I'm trying to figure out where this angle is, I can know right away that I know that there's a right angle for part of it, right? I see that it's a little bit past this right angle. Do you guys see that? So this right angle is negative pi over 2. Negative pi over 2. And essentially, if it went all the way around, right? If it went all the way around, then it would be at negative pi, right? So I can know that my angle phi, because it's been labeled phi here, I can know that it is somewhere between negative 90 degrees and negative 180 degrees. Or I could call this negative pi over 2 and negative pi. Do you guys kind of see that? So Christine asked, would the degree be negative 90? What we can see, Christine, is that it's a little bit past that, right? Do you see how the angle goes past the 90 degrees? So when we're working with this, guys, we just need to think about, well, what are angles that go a little bit past 90 or a little bit past pi over 2? Something that will be useful for us to do with that then would be to use our unit circle. So guys, in your notes, you should have the unit circle at this point in time. If you don't already have a unit circle in your notes, I want you guys to be making that as soon as you can, to be copying one down into your notes, or just finding one and keeping it somewhere that you can always have access to. Because really, using the unit circle is going to be a extremely common tool for us. The unit circle is a tool, and we love using it. And I really want to encourage y'all to use it. So I'm gonna copy and paste a unit circle into my whiteboard. So that way we can use it for reference. And so guys, we're trying to figure out, where is this angle here? Well, it looks like it's very similar to this one here at 4 pi over 3, right? Does that make sense to y'all, that it would be this one? Notice how it's probably not the 5 pi, it's probably not 5 pi over 4, because that would be if it was directly in the middle, right? That'd be if it was directly in the middle, which it's not. So it's just a little bit past 90 degrees. It looks like it's at 4 pi over 3. However, notice that we are not going in the positive direction, right? This is 4 pi over 3. We're going in the negative direction. So what would that be? Hong says negative 30. So negative 30 would look like this, Hong. Negative 30 would be over here, right? See how that's 30 degrees? Ah, negative 120, exactly. So Hong, what he recognized was that, what he's recognizing here is that this angle here, like how much past 90 am I? He's saying that this was 30. So then 90 plus 30 is 120. So actually, yes, he's right. Phi here is negative 120 degrees, exactly. Now, how would we write that in radian? Well, I know that actually this whole angle here was 4 pi over 3, right? And I know the whole circle is 2 pi. So what I could do is I could actually look at the difference between them to know how big this angle is, guys, right? If the whole circle is 2 pi, and I'm missing this 4 pi over 3 portion right here, then how much am I left with? A subtraction of the two. Yeah, exact. So I'm not gonna, so I see Hong is using degrees to talk about this, but I want to encourage you guys to start getting used to using things in radian, okay? So to subtract these guys, I need common denominator. So I'm gonna convert 2 pi into 6 pi over 3. You see that? Actually, here, I'm going to write it like this. 6 pi over 3 minus 4 pi over 3. And so 6 minus 4 is 2 pi over 3. And what I want y'all to see is that, check it out, y'all. This angle here should look extremely similar to this angle, the size at least. We're talking about the size, guys. The size of the 2 pi over 3 angle. Would you guys say those look like similar sized angles? In the lesson on Friday, I saw some people noticing that actually the negative angle would be directly below the positive angle. So this is 2 pi over 3, and this guy is negative 2 pi over 3. That is actually an interesting and cool pattern and feature to observe about the unit circle. So for example, if I instead had the angle of, let's say that I have 3 pi over 4, well, directly below that angle would be negative 3 pi over 4. If I had, let's say I had an angle that was so negative it went all the way around to pi over 3, right? So this is pi over 3. But what about the negative version of that? Well, I would do the exact same thing as this. I would simply take 2 pi minus pi over 3. 2 pi is 6 over 3, so I'd be left with 5 pi over 3. And so I would know that this guy here is negative 5 pi over 3. So by essentially, guys, using a taco. So essentially by using various kind of ideas of reflection, right? We're looking at kind of like reflection over the axes, or we're looking at kind of ideas of what's called coterminal, which we're about to talk about. You can always figure out equivalencies to these angles. Now that we've mentioned coterminal, let's go ahead and see that one. Let's go ahead and see coterminal, because that's actually, I think, the greatest thing for us to learn about right now. So so what were some answers people had for number 6? You can see here in Hong's for number 6. Here we go. Check out this. So he's got 30 degrees is a little bit below his 45 degrees, right? And negative 100 is a little bit more negative than 90, right? So you can see that it's gone past the 90 degrees to negative 100. Another one I took as a snapshot was for Lydia's, I think. Yeah, Lydia's. Where's Lydia? Here it is. So check it out. Similar idea to Hong's, right? So she's got 30 degrees, and then above that is 45, which is actually pi over 4, right? So you can see here, it actually asked us for pi over 4, guys. But she said, oh, pi over 4, that's the same thing as 45. That's cool. And then minus 100, a little bit past the 90. So let's go ahead and start looking at what is coterminal. All right, guys, what are coterminal angles? So the idea of coterminal, I was asking people earlier what coterminal meant. It means we've got, hey, wait, can I put annotations on this? Annotate. We've got coterminal, guys. What does co mean? Can people tell me what does co mean? What does it mean for saying, what does the prefix co mean?
Is like, yeah.
Yeah, same, alike.
Like two people in the same position.
Exactly. Exactly. So yeah, exactly. So co is like cooperative, for example, when people work together. Corporation is actually like also kind of has that co to it because it's talking about having a corporation kind of takes multiple businesses and brings them together under one umbrella and so on. So co means kind of similar, same, in the same position, right? Terminal, what does terminal mean, guys? What does terminal mean? Airplane, yeah, actually, yes, like an airplane. Why is it called, why is the parking spot for the airplanes called the terminals? Why are they called terminals? There's other words that terminal means, or that times when terminal gets used. Sections. That's a good idea. Final part. Final, or like the ending. Death. Yes, actually, it does. People use the term terminal to talk about a disease or some sort of condition which could cause someone's death, death being the end of their life. So the idea, guys, is that terminal means essentially ending. So coterminal, what are coterminal angles? They're angles that end in the same position, right? Because of the cyclic nature, right? Because unit circle, right? Or just any circle goes around and around and around and around, right? And it's just repeating itself over and over. What happens, guys, is that I can have angles which end up in the same location regardless of their journey. So I could have, for example, an angle which was just the negative version of this one down here. Or I could have an angle which goes all the way around. Or I could even have an angle which went around once, around twice, around 3 times, and to our position. Every single one of these angles is ending up in the same spot, meaning that they are all going to have the same coordinates on the unit circle. That's the kind of idea here, guys. So if I scroll down here, I'm going to turn off my annotations. If I scroll down here, you guys can see we've got a 45-degree angle, but other values which are equivalent to that were 405, because essentially, guys, if I take 45 degrees and I add 360, right, that's one full circle. If I add a full circle, then I should end up in the same position. And that equals 405 degrees. Similarly, if I go the other direction, right, if I do 45 and I take away 360, that gives me negative 315 degrees. So that's why these guys are all coterminal. Do you guys kind of see does that make sense to people? So by adding a full circle or taking away a full circle, I can end up getting coterminal angles. Yeah. I do appreciate, even if people are saying like yes, which kind of is not very actionable upon, right? Because like, you know, if someone says no, it doesn't make sense, then that's where I take action and I'm like, okay, well, how can we get this to make sense? But I still appreciate people saying yes a lot. It's helpful so that I can kind of get an idea of whether people are confident, because no response kind of tells me like maybe you're not super confident, but you're not yet sure how to ask for further. So cool. Okay, guys. So let's look at then a little bit about coterminal angles, right? Oh, I don't need these annotations here anymore. Okay, so guys, to find an angle between 0 and 360 degrees, this is a pretty common kind of thing to want for exercise for us to get asked when working with angles and trigonometry and stuff, guys, because if your angle is between 0 and 360, then that's where we're within kind of our standard unit circle. So if I have an angle like, for example, 1045, how can I actually solve this? Well, we have a couple people who did it for us. So here we have Zeus, Min, Rachel, and present. So you can see these guys here. So I thought that this was really cool what I saw here, guys. So check out in this one here first. Okay. So what this student did was they said, okay, I have 1045 degrees and I need to get an angle which is coterminal with it. So they subtracted 360 from it and get 685. Now, is this angle 685 coterminal with 1045? Is that angle coterminal, y'all? Yes, yeah, it is. It is coterminal. Now there's one problem here, guys. The question didn't ask us to find any coterminal angle. It asked for an angle which was between 0 and 360. Oops. Between 0 and 360, right? So what we have to do is subtract another 360. Exactly. That's what Christine said. She's saying take away 720. What you guys can do is, this is a perfectly reasonable way to do it. Just do one step at a time. You could take this and then subtract 360 again. And then you'd get, 325, I think. I don't like this question because it could have been a positive or negative coterminal angle. You mean in the result, Hong? Is that what you mean? The second one, and yeah, the result too. So actually, the result cannot be a negative because we were specifically asked for it to be between 0 and 360. So so if we look at essentially if we look at this one here, right, that the student did, so it's not negative 200. No, it's not. So I included this one. I included this one because I really liked how it showed that this student was starting to get the idea, right? They were finding coterminal angles. They just weren't going far enough, right? So I just kind of wanted to show you guys, like, so in this one, they needed to subtract another 360, right? And then they would get 325. Similarly here, for the second part, they had a negative angle. They wanted to find a positive coterminal. So they added 360, got negative 200, but they need to add one more 360. And that would give them with 160 degrees. And you can see that in this one here, the student has done just that. And they got angles which were within 0 to 360. All right. In the second part, we were doing the same thing with radian. And it works just the same, guys, except how many radians is one full circle? How many radians is one full circle? It's 2 pi, right? So you can see that here, this student, they subtract 2 pi from the 11 pi over 4. And when you're working in radian, guys, you're just essentially you're just getting a lot of practice working with fractions, which I think is a great thing because a lot of us can use more practice with fractions. So they subtracted 2 pi, which is equivalent to 8 pi over 4, right? 11 minus 8 is 3. All right. I liked this one as well over here because I thought the student showed their work really strongly. They subtracted 2 pi. It was 8 pi over 4, and they get 3 pi over 4. Looking at what else they did, then they took the negative one and they added 2 pi, right? And so if you guys can see here, once they added 2 pi, which is 10 pi over 5, they got negative 33 pi over 5. And they said, this is not positive, so I need to keep going. So they add another one, and they add another one, and they add another one, and they add another one. And they just kept going until eventually they got this positive value, 7 pi over 5. So what is all this coterminal angle stuff about, right? It's about basically, guys, can I take any possible angle in the world, even an angle like 10,000 could be turned into one which is within 0 to 360. An angle like 70 pi could be turned into one that is within 0 to 2 pi radian. All right. So that's kind of the gist of these coterminal angles. Do I have any questions about coterminal angles or negative angles? There's like I feel like there's like a cool, yeah, there's like a cool kind of like imagery that exists within, I can't find exactly what I want, but you guys can kind of see, maybe you can see like there's like this cool imagery of like imagining, see the blue axis. That blue axis represents essentially just the angles going around the unit circle, but being unraveled, right? So because I could go infinitely around the unit circle, I go infinitely in the positive direction, but I could also go to the negative direction. It creates our x-axis. Someone asked, can you do one more example with the radian for coterminal? Yeah, totally. Let's do, where am I? Let's go ahead and get this guy. Ready for more. Here, we'll solve these guys. So check it out. I've got this one here, and I have some negative angle, right? I have some negative angle, and I know that the positive version of it is 11 pi over 12, right? So how could I actually find this negative angle? Well, I could just take this position here and go one full circle, one full loop backward, right? Do you guys kind of see that? What is one full loop in radian? It's 2 pi, right? So to figure out the coterminal angle, right, the negative coterminal angle here, I just have to subtract 2 pi. 2 pi would be equivalent to 24 pi over 12. 11 minus 24 is negative 13 pi over 12. Does that make sense? I see Hong out here literally solving it. Yeah, this guy. He's like, no, I'm not doing my homework right now. Okay, so guys, what I'm gonna do is we're gonna go on forward in life. So that was a lot about this problem set that we were working on previously. Now, you'll notice I haven't talked about the trig function stuff yet, right? I have put together some slides for us to kind of talk about that because I thought that it'd be useful for us to kind of cover it a little bit more lesson-like than how this problem set does, okay? So first of all, let's look at the basic trigonometric ratios. So guys, from geometry, I'm hoping that the idea of sine, cosine, and tangent are familiar. But in case you don't know what they are, guys, here's what they are. Essentially, in any right triangle, right? Notice this is a right triangle. Why is it a right triangle? Because it's got a right angle. Boom, right there. In any right triangle, I can essentially understand the side lengths of the right triangle to be the opposite side, which is the leg opposed from the angle I'm focusing on, right? Angle of focus, right? Because notice, guys, there is one other angle here that I could be looking at. And in which case, if I'm looking at this angle, what's the opposite side now? It's down here, right? But let's stay with our focus angle. So essentially we have our angle of focus. The opposite side is the one across from it. The adjacent side is the one next to it. Notice that it touches the angle itself. And then we also have the hypotenuse, which is always this long side across from the right angle, okay? The idea of trigonometric ratios is that essentially, guys, no matter how big this triangle is, no matter how big I scale it, whether it's massive, it's miles long, or it's tiny, it's millimeters in size. Regardless, if it's a right triangle and it has this angle theta, the ratio between the side lengths, right, will always be the same, right? So essentially, guys, if I have, let's say that this was a 3, 4, 5 triangle, the sine of theta would be the opposite side divided by the hypotenuse, 3 divided by 5. Oops. However, let's say that I scale this triangle to be bigger, 100 times bigger. Oops. So it's 300, 400, and 500. The sine of theta would still be 300 divided by 500, which is equivalent to 3/5. Right? So what we notice, guys, is that essentially trig functions, they're like a reference table. In fact, in old math textbooks, if you look at a really old math textbook and you flip to the back of it, you'll be able to find these tables that just tell people like just a list of all of the sine, cosine, tangent values for angles of degree like 1, 1.1, 1.01, 1.001, and so on. And it's just kind of excessive, but it's because it was before they had calculators. Or it was like expected that you didn't have a calculator that could do trigonometry. But yeah, so the idea, guys, is that sine is just a relationship of the opposite side divided by the hypotenuse. Cosine is the adjacent side divided by the hypotenuse. And tangent is the opposite divided by the adjacent. So in this triangle that we have here, the 3, 4, 5 triangle, the cosine of the angle would be the adjacent over the hypotenuse, which would be 4/5. And the tangent of the angle is the opposite divided by the adjacent, 3/4. Oops. Right? So all these ratios will allow us to find things like, for example, if I did not know this side length, if I said that this side length here was x, I could figure it out by using one of these trig functions, right? Because I know that the cosine of this angle is supposed to be the adjacent over the hypotenuse, right? The adjacent over the hypotenuse. And I know that the cosine of this angle is 4/5. So I'm like, okay, well, if 4/5 is equal to the adjacent over 500, I can use this to solve for my adjacent side and figure out that it was actually indeed 400. So what I would like to encourage people to do is in your own notes, where you have your unit circle or where you will have your unit circle, I would really encourage you guys to have these ratios written down, okay? I'm gonna go ahead and actually, I'm gonna share my slides with you guys so that way if anyone needs to look at a, a slide that I've previously put down, you can look at that. So now, guys, I wanna show y'all new sets. These are called the basic trig ratios, right? Sine, cosine, and tangent. These are the ones that we learned in geometry. Now there are 3 more to introduce, and they're called the reciprocal trigonometric ratios. Essentially, guys, they're called secant, cosecant, and cotangent. I do not expect anyone to memorize all these ratios. I actually don't expect you to memorize it. I just want you guys to have it in your notes, and I would expect that you would be able to use it, okay? So let's say I had my 3, 4, 5 triangle again. Yes, exactly. Chateau cow. No, it's I like to do, actually, I like to call it Cho Shakao. Cho Shakao. If you don't know what I'm talking about, that's okay. Don't worry about it. Okay. So guys, let's say that we have our 3, 4, 5 triangle again. The secant of my angle is the hypotenuse divided by the adjacent. Well, my hypotenuse is 5. My adjacent is 4. So the secant of this angle is 5/4. Simple enough, yeah? SOHCAHTOA, yes. SOHCAHTOA is the thing that we use for the basic one. So essentially, guys, these are the trig ratios: sine, cosine, tangent, secant, cosecant, cotangent. My question to you guys is, if you compare the ratios of the basic with the reciprocal ones, how are they similar? How are they similar? They're solving for the angle. You could use them to solve for an angle. Exactly. That is one way that they're similar. How else are they similar, guys? They are fractions. They're ratios of the side lengths. That is another way that they're similar. Any other ideas of how these guys are similar? How are the reciprocal trig ratios similar to the basic ones? They do involve triangles. Yes, Hong. I want to point something out to you guys. Notice sine. What's sine? It's opposite over hypotenuse, right? Sine is the opposite over the hypotenuse. Do any of these ratios involve the opposite with the hypotenuse? Which one involves the opposite with the hypotenuse? Cosecant, exactly. Sine is opposite divided by hypotenuse. Cosecant is hypotenuse divided by opposite. They are called the reciprocal trig ratios because they are literally reciprocals, right? Flipped versions of the ratios from the other one, right? So essentially, guys, what this means is that if I annotate this, sine of an angle will be equal to 1 over the cosecant of that same angle. They're just flipped versions of each other, right? Because sine is the opposite over the hypotenuse, and cosecant is the hypotenuse over the opposite. Well, if I divide 1 by that, I get opposite over hypotenuse, right? Because it flips it. You guys see that? So cosecant is 1 over the sine. Secant is hypotenuse with adjacent. That is the opposite, or the reciprocal, I mean, of cosine. And cotangent is the reciprocal of tangent. You guys see that? I would really encourage people to include something like this written in your notes. So those are the reciprocal trig ratios. Now what we're going to do, guys, is we're going to go ahead and play around with it and solve some trig evaluation with these. All right. So let's see, trigonometry on the unit circle. Ooh, I wanted to show you guys one more thing actually that I thought is like, it's a cool image. So guys, imagine I have some angle on the unit circle, theta. This one looks kind of like it's about 30 degrees or pi over 6, right? Essentially, guys, remember, and I really encourage people to include this on on the notes for your unit circle. Remember that sine of any angle on the unit circle is equal to the y coordinate, right? Notice it's the y value on the unit circle. Do you guys remember that? So sine is always equal to the y coordinate of the unit circle. Cosine, which I have here in kind of like a violet, is always the x coordinate. You see down here? And then tangent was always the y value divided by the x value. All right. But something that's kind of interesting to observe, guys, is that actually the reason why it's called tangent is because you may or may not remember from geometry, but a tangent line is a line which is at a right angle to something, right? So watch this. See, notice how the sine and the cosine make a right angle. Imagine if this line here had a tangent which was touching at this point at a right angle. So imagine I have a right angle from this line and it connects to make a right triangle that's like pointing downward. Do you see that? This green line is like the length of this green line is actually from this coordinate tangent to the radius down to the x-axis is actually always the tangent. It's always what the tangent's equal to. That's why they call it the tangent line, because this line here in green is tangent to the circle. It makes a right angle with this radius on the circle. This is a little bit of bonus knowledge, just so you guys know. But like I like kind of seeing these things because I feel like it makes it. It's like, oh, okay, so like I can see all these triangles, and in fact, those reciprocal trig functions also have other lines which you can throw in here and visualize. So kind of cool thing. So guys, we're going to go ahead and take some time to evaluate some trigonometric expressions. So we're going to evaluate the following using the unit circle. So the first one should be pretty easy. This 7 pi over 4 is on our unit circle. Can someone, I want people to try to think about what that one is. So what would be the sine of 7 pi over 4? Look at your unit circle, guys. Look at the unit circle. Where's 7 pi over 4? Right? So if I want to find the sine of it, what we're going to do is we know that sine is the y coordinate on the unit circle. So all I have to do, guys, is look at my thing. I see a lot of people saying 315. 315 is 7 pi over 4 in degrees. So 7 pi over 4 can be, you can convert radians into degrees, guys, by essentially saying, well, the ratio between radian and degrees is 180 degrees to pi radian. So if I multiply this by 180 over pi, I actually do end up getting 315. But that is the same angle. That's not what sine of the angle is equal to, guys. Remember, sine is that ratio, okay? So looking at my unit circle here, y'all. Looking at my unit circle, look at here. Here's 7 pi over 4, guys, aka 315 degrees. The y coordinate here is negative square root of 2 over 2. So that is actually my answer. That is negative square root 2 over 2. And that's because if you guys remember, sine of an angle is always equal to the y coordinate on the unit circle. So you guys see, so when we're evaluating trig expressions, guys, what we're doing is we're first seeing, I'm first trying to figure out where on the unit circle is this, what are the coordinates in that location, and what coordinate am I looking for? Where will I post the link to the recording? I I will post it on Google Classroom. The recording will be posted on the same YouTube channel that I post all my videos on. But yeah, I'll as soon as it's uploaded, I'll post something on Google Classroom. Hi YouTube, says Hong. All right, so guys, let's keep going. Tangent of 495. Now this is where it's getting a little bit more challenging, guys. Because this angle is not on our unit circle, we need to figure out what its coterminal angle is, right? So we need to figure out what 495 is equal to. How do I do that? We're gonna take away 360, exactly, Christine. So we take away 360 and we get, yeah, Millie says -1, as in we're taking away one circle, right? So we take away one full circle and we end up getting 135 degrees. So essentially, guys, if I look at my unit circle, 135 is right here, right? 135. Imagine if I had instead gone a full loop and got 360 plus another 135. That's the angle of 495. That doesn't look so good. Oh, you meant the answer was -1. Yes, you are correct, Millie. So so what we'll see is this is 495. So Millie said, okay, well, the coordinates at 135 are -√2/2 for the x and √2/2 for the y, right? Tangent is y/x, right, guys? So we would take √2/2 and divide by -√2/2. If my values are the same, guys, you should always get 1, but a positive divided by negative is still negative. So that's how Millie got -1 for her answer here. Does that make sense to folks? She said √2/2 divided by -√2/2 is equal to -1. Now, guys, you'll notice that I'm drawing these unit circles here, right? And but I would expect people to be using their own unit circle to find these coordinates, okay? I don't need people to have these coordinates memorized. I just want to, I know I keep saying that, but I just want to keep reiterating it because I just want to make sure like people don't think that like, holy shit, how's Mr. Hobart already expect us to have this unit circle thing memorized and all that? I don't, okay? Okay, I know that we're running out of time, guys. Well, we did run out of time, but I want to do this secant one real quick, just because it's a negative angle, so it's kind of cool. So we have -2π/3. To get a coterminal angle, we're just going to add 2π to it, and that would give us 4π/3. Okay, so the secant of 4π/3 is equivalent to this guy, right? They're equivalent to each other. Hong said Shaw. Is secant the hypotenuse over the adjacent? I believe it is. Yes, so it's hypotenuse divided by adjacent. So what we need to do, guys, is we need to look at our unit circle for 4π/3. So if I look at the unit circle, 4π/3 is right here, and its adjacent side, which, guys, is the adjacent the x or the y coordinate? That's a good point. Is adjacent the x or the y coordinate? It's the x. It is, right? See how the x, I know that my drawings are in the way here, huh? Let me get my drawings out of the way. See how the x coordinate, guys, the x coordinate here is the adjacent side, right? So as we're evaluating these guys, the secant of -2π/3, we are looking essentially at the x coordinate here of 4π/3, which was -1/2. So this should be equal to hypotenuse, hypotenuse over the adjacent, which is 1, right? Remember, guys, in the unit circle, the hypotenuse is 1. So it's hypotenuse over adjacent. Hypotenuse is always equal to 1. The adjacent was -1/2. What is 1 divided by -1/2 going to be? We're going to flip the reciprocal, right? And multiply. 1 times -2 over 1, which is -2. So the secant of -2 pi over 3 is -2. All right, guys. Cool. So that is, I think, going to be it for our class today. I know that was quite a bit of lecture, which is not as much what I intend to do on Tuesdays, but today kind of just, that's how it ended up being because of how things left off from last week. Let's see, we don't really need to do this part. Evaluating sine. Yes, this sine values table. This is something that I wanted to do, but we will have to do it another time. All right, guys. So you can look forward to this in the future. Otherwise, our class is coming to an end. Feel free to say your goodbyes before you leave, please. And I will see y'all next time. Goodbye.